ray diagrams for plane mirrors. On the screen right now, you're looking at everything you're going to need. Pencil, protractor, and a ruler. All right, and you're going to have a diagram. We got our mirror and our hard surface on this side and the reflective surface on this side. So all the light is over here and it's coming at this from all directions, but we're only going to draw a few of the rays. This here is our object, and the top of it we're going to call point A of the object, and the bottom we're going to call point B of the object. Okay, so you're going to be using a pencil, but I'm going to use a couple different colored markers to help us visualize and see what's going on. So to start, we're going to draw a ray of light that travels from point A of the object to the mirror and straight backwards. Okay, it's going to travel from the point to the mirror and it bounces right back. But we're also going to put some dots on the back end as a representation of the ray traveling behind the mirror. Because with plane mirrors, the image is going to be a virtual image, and it looks as if the object is going to be inside the mirror, which is in fact not the case, but that's why we draw these diagrams as sort of a representation thereof. So the second ray we're going to draw comes from a point A, but it's a reflection. Or sorry, it comes at an angle. So it comes from the point and it hits the mirror like this. Okay, just to show you here, the light travels this way, bounces off backwards. So now we got a ray that travels from the point, hits the mirror at an angle. So we're going to measure this angle, and you know what? It's going to help if I draw a normal. I'm going to use my pencil for that. This dotted line here is the normal, and it's what I'm going to use to measure the angle of incidence. Okay? And it appears to be about 18 degrees. So this angle here, the angle of incidence, we're going to say is 18 degrees. That means from here, it's going to be also 18, oh, no, my bad. 18 degrees. So about here. So then we're going to take our ruler, a red marker, we're going to draw the ray. It reflects, so the ray of light reflects off the mirror at this angle, but we're just going to draw some points again as a representation of the ray traveling through the mirror. See, they intersect over here. More on that later. So the angle over here is also 18 degrees, and it's the angle of reflection, because if you'll remember, the angle of incidence must equal the angle of reflection. So then I'll take another colored marker. We're going to use a blue just to help with the visualization of it all. And it's going to go from point B of the object. And as I said, the light bounces off comes off point B, bounces off the mirror, reflects straight backwards. And then we're going to extend the reflection back. Okay, comes off point B and bounces straight back. All right, we're going to choose a different angle now from point B we're going to say it hits the mirror there. Okay, travels from that point that way. And we're going to call this the normal. The normal, as you know, travels perpendicular to the mirror. And we're going to measure it. We're going to measure with our protractor this. Oh, wait. What am I doing here? Okay. Where that's lined up. So it's about 30 degrees. Okay. So I'm just going to mark it here on my page, and then I'm going to use my blue marker to draw the reflection of the ray. Goes that way, but we're going to draw some dots coming behind the mirror just to represent the reflection. Bounces that way. Okay, because here the angle of incidence equals the angle of reflection. And now, where this point here, we can draw from here to here. Where is it? And so there is our image. And we're going to call this point A of the image and point B of the image. And it doesn't look perfect, so we can double check. If we measure to this point to this point is about 2.9 centimeters. So this point to this point is about, 2.9. And that's 2.1. This here is 4.3. And this is 4. Okay, so it's not perfect. You can tell that it looks like there's more of an angle here than it is here, which means I probably made a mistake measuring my angles. And so let this be a lesson to you that if the angles are perfect, then the object will be a perfect reflection. Sorry, the image will be a perfect reflection of the object. All right, it gets a little bit messy with all the dots and the lines. I understand that. But hopefully we have a better understanding now of how images are produced in mirrors. And so when we look in a mirror at ourselves, if we're standing over here, it looks like we're back here in the mirror. But light is not actually bouncing off of us back here. It's bouncing off of us here and then to the mirror so that our eyes can see it. Okay, so next we're going to look at concave mirrors.